Hello everyone. In this presentation, we will be going through the topic engineering curves, which falls under the module number 1 of our syllabus for the subject of engineering graphics. So now let's start with the topic. Let us see what is the definition of cycloid first. It says that a cycloid is a curve generated by a fixed point on the circumference of a circle when it rolls without slipping along a straight line. Now, what is the meaning of this statement? Let us consider this is the circle that we have and it is rolling along this horizontal plane without slipping. Its circle will be having n number of points around its circumference. So if you consider any of the point on its circumference and trace the path of that point when this disc is rolling along this without slipping, then that path traced or the curve generated will be called as what? Cycloid. Now let us say this is the standard question for this particular topic. A circle of 40 mm diameter. So diameter of a circle is given to us and it is said that it is rolling along a straight line without slipping. So when this thing comes here itself, we should understand that it is a question of cycloid. Then what is the next line? Draw a curve traced by a point on the circumference for one complete revolution. Now this is the thing that is of most important in the question. What? It is rolling for one complete revolution. How that affects, that we will be seeing later on. Name the curve. So the path trace that you will be drawing, in the end you have to name that curve. Also you have to draw the tangent and normal to the curve. At which point? At a point 25 mm above the straight line. So what I will do, I will just explain you the generalized procedure. While going through the video, after each slide, you have to pause this, follow this step and then continue with the next slide. So now, what is the question? We have a circle of 40 mm diameter. So first thing that you will be doing is, you will be drawing a circle of diameter 40 mm. Depending upon the question, this will vary, but the procedure will be drawing the circle. So step 1, draw the circle of the given diameter. Pause the video and do the needful. Now in next step, what we are supposed to do is, the circumference of the circle that we have drawn, it has to be divided into 12 equal number of parts. I hope you all know how to divide this into 12 equal number of parts. What you can do is, you can take distance equal to radius of the circle into your rounder. Keep rounder on this point. Mark a point here, mark a point here. Similar manner, keep rounder point here. Mark this and this point. Keep rounder over here, this and this point, and mark. And rounder over here, this points you will get. When you do it accurately and you draw a lines passing through the center, it will be seen that these are the lines which will be coinciding at the center point C of that circle. Complete this step. Now next step. We have drawn the circle in first step, then we have divided this circle into 12 number of equal parts. Now in the question it is given that it is completing one complete revolution. One complete revolution is nothing but this entire circumference distance that the disc has traveled. How the circumference of that circle is taken? Yes, by formula pi d. So whatever is the circumference over here, we will open that as a straight line, as it is said that it is rolling on this horizontal line. Since this circumference is divided into how many number of parts? 12 number of parts. This has also been divided into 12 equal number of parts. So for that, what you will be doing, you must be knowing the procedure of dividing a given line into 12 equal number of parts. You will be drawing a line at an angle theta with respect to this line, which is to be divided into 12 equal number of parts. Take a random distance, let us say 1 centimeter in your rounder, and starting with point 1, go on marking point 1 dash, 2 dash, 3 dash, 4 dash, up to 12 dash with the same distance in the rounder. Once you get all this point, you have to join this point 12 dash with this point 1. Now this point 1 is located at distance of pi d. Since we are given with the 1 complete revolution, that's why we are considering this as to be pi d. Once you are done with joining this, what you will do, you can keep your drafter or roller scale parallel to this line, and you can go on drawing a lines from each of the point 11 dash to 1 dash respectively, which will give you these points, which are nothing but dividing this pi d distance into 12 equal number of parts. Also, you have to draw horizontal lines from each of this point. So if you are doing it accurately, there will be line passing through 2 and 12, which will be a straight horizontal line. Same will be there with 3 and 11, 4 and 10, 5 and 9, 6 and 8 at point 7. So this is the next step that you have supposed to be followed. Now the next step. Can you observe what we have done over here? The points that we have got after dividing this into 12 number of parts, from those points we have drawn a vertical line which is perpendicular to the rolling plane. So from point 1, the line that we have extended and which is meeting the horizontal center line of this rolling circle is named as C1. Same with C2, C3, C4, and it is up to C11. And the last point where the rotation is being terminated, it is named at C dash. Follow this step. Now next thing that we have to do is, we currently do not know which point's path is to be traced. You can trace the path of point 1 or 2 or 3 or 7 or 10. When nothing is mentioned, for now we have taken point P at this particular position. Let us say this disk is completing 1 complete revolution. Means what? This point will start rolling and it will be reaching at particular point, and at pi d distance it will be again coming in contact with the rolling surface. So now how to trace this curve? This centers we have got from C1 to C dash. Take a distance equal to radius of that circle into your rounder. Keep your rounder on point C. Mark the first point P. So this is your first horizontal line. Next step, what you will do, now with the same radius R, keep your rounder point on C1 and mark another point on the second horizontal line. That will be your point P1. What will be the next step? Keep your rounder on point C2, mark on third line. Then rounder on point C3, mark on this fourth line, which will give you point 3. Now center C4 and the another line, this will give you point 4. Center C5, the above line, point 5. Center C6, here you will observe that it will be the maximum distance which is traced by the point or maximum height. Then again C7, come one line down, C8, another line down, C9 on the center line, C10, one below that, C11, again one below that, and C dash exactly at this end. So this is how you are going to get the points P1 to P dash. So next what you are supposed to do is, you have to take help of a French curve and you have to join all these points. Now this points or the curve traced by this point is nothing but the path traveled by the point P when it is rolling without slipping for 1 complete revolution. Now let us say another case. This is the direction of rotation. Initially what we have done, we have traced the path of this point P. Now let us say this is the point whose path is to be traced. Now all the procedure will remain same up to dividing that circle into 12 parts, dividing that circumference into 12 parts, then locating the center. Now how you are going to start is, again take the distance equal to radius of that circle. put rounder over here. This is the first point that you have. What you will be doing next, keep your rounder on point C1. On second line, you will be getting point P1. Now, keep your rounder on C2. On the next line, you will get point P2. C3, point P3. C4, point P4. C5, point P5. And again point C6, the point P6. In this manner, we have to continue. C7, again one line above. C8, above. C9, one line above. C10. Accordingly, we have to reach up till P dash. So it has started over this top point and it will be ending over this top point. So the curve traced now is in this manner. So as point on the circumference changes, the path traveled by this point will be different. The procedure to locate that path will be same, just starting point and end point that you have to take care of. So this is the exercise that we want you to follow. So this was up to drawing the curve. What we are asked to draw is normal and tangent as well. So for that, what is the step that we will be doing? The point. Now in this question, it was mentioned that the point is 25 above the ground level. So with respect to ground level, at 25, wherever the point comes on this curve, there you have to mark this point M. This is the first step that you will do. Then what you will do, take a distance equal to radius R. Means if this is diameter D, half of that will be your radius R. So from this point M at radius R on this horizontal center line, you have to take this point Q. Pause the video and do up till this. In the next step, what we will be doing is, from this point Q that you have got, you have to draw a straight vertical line which will be perpendicular to this rolling surface. So now this is your point N. So you have got point M, point Q and point N. In the next step, what we will be doing, we will be drawing a line which will be passing through N and M. Now this line that we have drawn right now is nothing but the normal of that cycloid. And how to get a tangent? Tangent is a line which is always orthogonal to this normal. So what we can do is, in the next step, this normal and N dash we have got, you have to take your scale and you have to draw a perpendicular line to this which will be passing through point M, and you will get this line T dash, which is nothing but the tangent of the cycloid or cycloidal curve that we have traced. And also in the question it was asked that name the curve. So you have to name the curve that you have traced till now. So this is the standard procedure to draw a cycloidal path and its normal and tangent. So now here are few questions for you. What if the disk is rolling for half revolution? If it is rolling for half revolution and it is rolling for 1.5 revolution, in which step changes are to be done? Think on this, and this will be discussed in our lecture when we will be conducting it online. Thank you for watching the video.